In this video, we're going to talk about how to convert binary numbers into decimal numbers. And we're going to go through plenty of examples so you can master this topic. Let's start with this example, 1010. How can we convert this particular binary number, which is a base 2 system, the digits can only be 0 or 1, how can we convert it into a decimal number? Now the first value is 2 to the 0 power. And the second one is going to be this number times 2 to the first power. And the third value, going from right to left, is 0 times 2 squared. And this one is going to be 1 times 2 to the third power. So 1 times 2 to the third power, that is equal to 2 to the third power. And then if we multiply 2 squared by 0, that's going to give us 0. And we're going to add these values. And then it's going to be 1 times 2 to the first power, which is just 2 to the first power. And then 0 times 2 to the 0 is 0. So everywhere you see a 0, you could ignore it. So we only need to focus on the numbers that contain a 1. Now, let's add up these numbers. So what is 2 to the third power? 2 to the third power is 2 times 2 times 2, which is 8. 2 to the first power is simply 2. So we're going to get 8 plus 2, and so the answer is 10. So the binary number 1010 has a value of 10. Now let's try another example. 10010. So if you want to try it, feel free to pause the video. Go ahead and write this number down and convert the binary number into a decimal number. So let's start from the right side. This is going to be 2 to the 0 power. The next number is 2 to the first power. It's 0 times 2 to the 0, by the way. And then the next number is going to be 0 times 2 squared, and then 0 times 2 to the third, and then 1 times 2 to the fourth. Now, we don't need to worry about the zeros, so let's ignore those numbers. Focus on the numbers that have a 1, because those numbers will contribute to the final answer. So this is going to be 1 times 2 to the fourth power, which is simply 2 to the fourth power. And then this is 1 times 2 to the first power, which is just 2 to the first power. So what is 2 to the fourth power? So 2 times 2 times 2 times 2. 2 times 2 is 4, and 4 times 4 is 16. So 2 to the fourth power is 16, plus 2, and so this will give us 18. And so it's not very difficult to convert a binary number into a decimal number. As long as you follow the process, you're going to get this right. Now, here's some information that you may want to know. 2 to the 0 power is 1. In fact, anything raised to the 0 power is 1. 2 to the first power is 2. 2 squared is 4. 2 to the third is 8. 2 to the fourth is 16. And then 2 to the fifth power, that's 32. 2 to the sixth is 64. 2 to the seventh is, that's 128. And then 2 to the 8 is 128 times 2, or 256. And so, if you know these values, you can quickly perform the operations that's necessary when converting a binary number into a decimal number. So let's try another example. 11011. So go ahead and convert this number into a decimal number. So this is going to be 2 to the 0 times 1, and then 2 to the first power times 1, 2 squared times 0, 2 to the third times 1, and then 2 to the fourth times 1. And just like before, we are going to ignore the 0 values and focus on the numbers that have a binary value of 1. So this is going to be 2 to the fourth, and then plus 2 to the third power, and then plus 2 to the first, and then plus 2 to the 0 power. So based on that table, or rather the information on the last page, We said that 2 to the fourth power is 16. 2 to the third is 8. 2 to the first is 2. And 2 to the 0 is 1. So now let's add. 16 plus 8 is 24. And then 2 plus 1 is 3. So the final answer is 27. And so that's how we can convert a binary number into a decimal number. Now, for the sake of practice, go ahead and try these two example problems. So convert these two numbers into decimal numbers. Feel free to pause the video and work on these problems. So let's start with the first example on the left. So I like to space out the numbers. It makes it easier. So this number is going to be associated with 2 to the 0 and then 2 to the first. And then we're going to follow the same process for all of the other examples. And now let's focus on the numbers that contain a 1. So what we have is 2 to the 6 plus 2 to the fifth power plus 2 to the first power and then plus 2 to the 0 power. So 2 to the 6th power, we said that's 64. 2 to the 5th is 32, and then plus 2 plus 1. Now 64 plus 32, that's 96. 2 plus 1 is 3. And so the final answer for the first example is 99. And so that's it for this one. Now let's move on to the next one. So let's rewrite the number. So we have 0, 1, 0, 1, 0, 1, 1, 0. And let's write these numbers at the top. And once again, let's focus on the numbers that contain a 1. Now let's add up these numbers. So this is going to be 2 to the 6 plus 2 to the fourth power plus 2 squared and then plus 2 to the first power. So 2 to the 6 is 64, 2 to the fourth is 16, 2 squared is 4, and 2 to the first is 2. So 64 plus 16, that's going to be 80, and then 4 plus 2 is 6. So the final answer for this example is 86. Now what if you're given a fractional binary number? How can you convert that into a decimal number? For instance, let's say if you have the number 1, 1, 0, 0 with a decimal point and then 1, 0, 1. How can we convert that into a decimal number? So the first number that's to the left of the decimal point, that's 2 to the 0 as always, and then 2 to the first, 2 squared, and the last one is associated with 2 to the third. But what about the numbers to the right of the decimal? Well, if we follow the pattern of exponents that we see here, the number that's less than 0 is negative 1. So this has to be associated with 2 to the minus 1, and then to the minus 2, and then 2 to the minus 3. Just like before, we're going to focus on the values that bear a 1. And so we're going to add 2 to the third plus 2 squared plus 2 to the minus 1 plus 2 to the minus 3. Now 2 to the third is 8 and 2 squared is 4. But now what is 2 to the minus 1? We know 2 to the first power is 2, so 2 to the negative first power is 1 over 2. Now 2 to the third is 8, so 2 to the negative third is going to be 1 over 8. And so 8 plus 4 is 12, and then we have 1/2 plus 1 over 8. 1 over 2, if you type that in your calculator, that's 0.5. And 1 over 8, 1 divided by 8 is 0.125. So adding up these three numbers will give us this answer, 12.625. And so that's how we can convert a fractional binary number into a decimal number. Now earlier we said that 2 to the fourth is 16. So 2 to the negative 4 is going to be 1 over 16. 2 to the fifth is 32. 2 to the negative 5 is 1 over 32. So notice the pattern that you see here. 2 to the 6 is 64. 2 to the negative 6 is 1 over 64, and so forth. So when dealing with fractional binary numbers, whenever you have negative exponents, just consider the ones with a positive exponent. So if 2 to the 7 is 128, then you know 2 to the negative 7 is just 1 over 128. So here's another example that you could try. 10011.011. Go ahead and convert that into a decimal number. So let's begin by putting the appropriate values next to each number. So on the left it's going to be 2 to the minus 1, 2 to the minus 2, and 2 to the minus 3. So let's focus on only the ones that we see. So it's going to be 2 to the fourth power plus 2 to the first power plus 2 to the 0 power, and then plus 2 to the minus 2 plus 2 to the minus 3. 2 to the 2 to the fourth power is 16, and 2 to the first power is 2, 2 to the 0 power is 1, and then 2 to the negative 2. If 2 squared is 4, 2 to the negative 2 is 1 over 4. And if 2 to the third power is 8, 2 to the negative third power is 1 over 8. So we have 16 plus 2 plus 1, so that's 19. And then 1/4 is 0.25. And 1 over 8, we said that was 0.125. So adding these three numbers is going to give us the final value of 19.375.